Of the circuit design in this video will mainly have the positive terminal and negative terminal where a 5V is applied across it. They are also connected to the switches, which determines the output to be 1 or 0. Positive terminal for 1, negative terminal for 0. There is also the power supply, which is connected to the top VCC pin, as well as the bottom corner GND pin, which is connected towards the ground. The input from the switches will go through each of the following gate IC chip to verify the output. The output will go through the resistor at the end to prevent things like current overload after going through the LED. First, we have the NOT gate. So now the current state is 0 and the output would be 1. And when I switch to 1, the output will be 0. And 0 become 1, 1 will become 0. It inverts the input. Next, we have the OR gate, which have two input, and plus them together, it'll get the output. So now it's 0, 0, the output will be 0, and when I switch it to 1, it will become 1, and when I switch it to 0, 1, it will also become 1. When both become 1, it will also become 1. Now this is the NOR gate, which does the exact opposite of an OR gate. It also has two inputs and one output. So now currently it's 0, 0, so the output is 1 as shown in the LED. And now it's 1, 0, it will become 0, and 0, 1, it will become also 0. Then when you switch it to 1, 1, it will become 0. This is the AND gate, which also has two pins and it multiplies the input. So currently the output is 0 when it's 0, 0, and when it's 1, 0, it's also 0, and when it's 0, 1, it will also be 0, and when both are 1, the output will finally be 1. So this is the NAND gate, which does the exact opposite of an AND gate. And now currently the switch is 0, 0, which the output is 1. And when you switch it to 1, 0, the output is still 1. And when you switch it to 0, 1, the output is still 1. When both are 1, it will become 0 instead. Next, we have the replication of XOR gate, which consists of one NOT gate IC chip, one OR gate IC chip, and one AND gate IC chip. We have both switches, we represent A and B, and we need to do a formula of A times NOT B plus NOT A times B. Then we'll get the output at the final LED. When both switches are the same, the output will be 0. But when both switches are different, the output will be 1 instead. So currently both switches are in 0, 0, so the output will be 0. And when I switch it to 1, 0, which is different, it will become 1. And when I switch it to 0, 1, it will be also different and it will also become 1. And when both are 1, which is the same, it will become 0. So the next one is XNOR, which is the opposite of a XOR gate. It does, well, exactly the opposite thing. So basically, when the switch both are at the same state, it will become 1, and when they are different, it will become 0. So currently, when they are both 0, the output will be 1 since they are the same. When I switch it to 1, 0, it will become 0, and so will be 0, 1. It will also become 0, and when I switch it to 1, 1, it will become 1. So as long as they are the same, they'll become 1, and when they are different, they'll become 0.